is a review for a chapter in Algebra 1 about polynomials. The topics are going to include talking about some vocabulary here at the beginning, adding and subtracting and multiplying polynomials, and then a big chunk of time is on factoring and solving by factoring. So we start off with identifying the leading coefficient and classifying the polynomial by degree and by number of terms. And so to kind of review the vocabulary there, the leading coefficient is the first number in the problem if the problem's in standard form. Standard form means that the biggest exponent is first, and then from there you make the exponents count down. So in this first problem, for example, this has the biggest exponent, so it would go first. And then the next biggest exponent is this 2, so that term would go second. And then finally this, which has an exponent of 1 that we just don't write, would go last. Now that it's in standard form, the leading coefficient is the number at the very beginning. Since there's not a number, it's just a negative, it'd really be like a -1. So our leading coefficient on this first problem is -1. We also want it to be in standard form to classify by degree, because the degree has to do with the biggest exponent. So we don't have to have it in standard form as long as we remember that we need to look for the biggest exponent. The words that we use to classify by degree, going in order from 0 and up, is a degree of 0 is a constant, and that means there's not an x at all. Then we have linear, which is a degree of 1, so that would be where you have an x, but it doesn't have an exponent because it really is an exponent of 1. Then we've got squared terms, which is quadratic. Then we've got third powers, which is cubic, which if you remember that another way to say x to the third power is x cubed, that should help you remember the word cubic. Then we've got some weird words. If you happen to know Latin, that might be helpful. The degree of 4 is quartic, and the degree of 5 is quintic. So as you're memorizing these, or if you're being tested over them, it might be helpful to come up with some acronym to memorize them in order, although we've got 3 Q's here, so good luck with that acronym. Just so that you can remember what order they go in, and then that will make it easier, and you can just write it somewhere on your test as soon as you can so that you don't have to worry about remembering it for the whole test. The way we classify by number of terms, I think, is a lot easier because it takes the end part of polynomial and it sticks prefixes that in theory should make sense. If we have one term, we call it a monomial. If we have 2 terms, we call it a binomial. And if it has 3 terms, we call it a trinomial. So, and then anything bigger than 3, we go back and call it a polynomial. So polynomial would be used for 4 terms and above. So I started number 1 talking about the leading coefficient. Now we can classify by degree. It has the biggest exponent is 4, so it would be quartic. And there are 3 terms here because our terms are typically separated by positives and negatives. So 3 terms is a trinomial. And that's the 3 things the problem asked for. On a problem like number 2, it might be helpful for you to put the things that we just generally don't write, which is that there is a 1 in front of x, because there is just one x here, and that the exponent for that x is the first power. It doesn't make sense to put any other number there. If I put a 0, x to the 0 is not the same as just x. If I put x squared, that is not the same as just x. It has to be a 1 right there. So our leading coefficient, if there's only one term, this is already in standard form. Our leading coefficient has to be that 1. Our degree is the first power, which is linear. And since there's only one term, this is a monomial. On 3, there's only one term again, And so whatever this number is has to be the leading coefficient. We can think of it like there's an x to the 0 out to the side. If you remember from earlier chapters that you might have studied, x to the 0 is the same as saying 1. So this would be like -6 times 1, which is -6. The other thing to just think instead is to say, when there's not an x, that's a degree of 0. There's 0 degree because there's 0 x's. And the 0 degree is constant. We also in math and science use the word constant whenever we have just a normal number. So that's another way to remember it, possibly. And there's only one term, so this is a monomial. And this last one, this is in standard form because we've got the 5 first and then a 1. It's by exponent, not by number in front of your variable, that we put it in standard form. So this first number is our leading coefficient. The 5 tells us that this is quintic for our degree, and there are 2 terms here, so this is a binomial. So that is how we identify the leading coefficient, classify the polynomial by degree and by number of terms. Let's move on to some operations. Like in this set of problems, we've got addition and subtraction. The important thing to remember with both addition and subtraction is that in order to add or subtract polynomials, we are looking for like terms. You are only allowed to add x's and x's together, x squareds and x squareds, x cubes and x cubes, numbers and numbers. So the other thing is that when I have subtraction instead of addition, that I actually think of this like I'm distributing a -1. And so what would happen is that would change this to plus, and that these signs inside would change. It kind of baffles me that I see students all the time draw these arrows, but then not actually change these 2 signs. That is the whole point of drawing the arrows, is to say, I'm going to change these 2 things based on what I'm drawing an arrow from. So make sure you do that. The beginning parentheses here would have a +1, and if I distribute a +1, it doesn't change anything. So the first parentheses should stay the same. It's the second one that should change. And because I distributed the -1, now this is just an addition problem. So one of the ways that we can do this is we can take the second parentheses and line it up underneath the first parentheses based on like terms. Like -8x squared would go under the 5x squared because those are both x squareds. 6x to the 4th would go underneath the x to the 4th. And then we're just going to add in our columns. So that's -3x squared plus -1 plus 6 is 5x to the 4th. Notice I didn't change my exponents. If I have x squared plus x squared, it's still x squared. Just like when you add apples and apples, it's still apples. It doesn't magically change to some other fruit. So when I'm adding like terms, my exponents don't change. When I multiply polynomials together, that's when my exponents change. But we're not doing any multiplication here aside from distributing that -1 at the beginning. This is not quite the correct answer because it says to write in standard form. So I want to switch these around because I want the biggest exponent first and then the exponents to count down after that. So number 6, we look in the middle, it's a plus. So we don't need to change any signs in either parentheses. I'm going to take this, the second parentheses, and I'm going to put it underneath the first parentheses, trying to match things up. So for instance, the -8n goes under the 2n, and the -8 goes under the 7. The problem is 3n squared doesn't have anything to go underneath, so we could put it out here to the side. I can add in my columns here. 7 minus 8 is -1. 2n minus 8n is -6n. This didn't have anything to add with. And this didn't have anything to add with. And this would be the correct answer, except I have to rewrite this in standard form. So I start with the 4th power, and then there's not a cube, so I go to squared. And then I do the just normal n, and the number always ends up being last. Our number should always be our smallest degree. Number 7, we want to make sure every single time we do a problem like this that we're checking to see what's in the middle here. A minus sign in the middle means we're going to take this and distribute so that it will be negative 7r minus 2r squared and positive 5. A lot of people will just make marks right here, and that's fine as long as you can read that and keep track of that. I feel like sometimes that's part of our problem. The other way, aside from writing underneath, like I did on 5 and 6, would be just to look at the two parentheses. For instance, I only have a single r cubed, and that's my highest power, so I can write down 6r cubed. Then I would look and say, okay, I've got a 3r squared minus a 2r squared, which is a 1r squared. And then I even go so far as to mark out what I've used to make sure that I use everything, because at the end everything should be marked out, or the last thing you use should be marked out. So next is r's. 5r minus 7r is negative 2r. And then 2 plus 5 is 7. So lots of people will either just not mark that out, or you can mark it out. And because I did it based on the highest exponent and counting down, it's already in standard form that way. So either of those two ways of writing down and showing your work are pretty much acceptable for most teachers, I would say, at least. On number 8, we're actually adding 3 polynomials together. Well, we're not adding them all together. We're adding 2 and then subtracting 1. So at some point along the way, we're going to need to distribute that negative, like so. And then these other 2 don't change because they are both positive in front. What we can do is we can add them all together at the same time, or we could do the first 2 and then use the third one after the fact. So I personally like to do them all at one time. And this even would be a case where we could write them all vertically again like before. We've got negative 3p to the 4th, 7p to the 4th, and minus 7p to the 4th. And those are going to add up to be negative 3p to the 4th, because these would cancel each other out. And then our p cubes, we've got 8p cubed minus 1p cubed minus another 1p cubed. So that would give us 6p cubed. And because I rearranged it, it's already in standard form, because the 4th is the biggest power and it's in there first. So that's adding and subtracting. Now we are going to multiply. These instructions say find each product, so that means that we want to use the sorry about that. We want to use the distributive property or FOIL or a special product maybe in order to figure out what these are. So I will say that you can always just think of it like the distributive property. And if there's one thing outside the parentheses in particular, that's what we need to do, is work on distributing this. Now that we're multiplying, multiplication happens in 2 parts. We do the 2 times the 5 and we get 10. And then we do the v cubed and the v squared together, which makes us add exponents, which gives us v to the 5th. Then we're going to do the next one, 2v cubed minus 5v, and get negative 10v to the 4th. We add the exponents. I don't know if I said that already. 3 and 1 add together to get 4. So then we do 2v squared times 2, which gives us 4v cubed. And that is our answer, because it's already in standard form, 5, 4, 3. And there aren't any like terms because those are all different exponents. Now for 10, there's 2 ways of doing this. One is to say I'm going to distribute 2p to both of these, and then distribute 1 to both of these, and then add like terms. The other way to do it is using an acronym called FOIL, which stands for first, outer, inner, last. So what it's telling us to do, and it literally ends up being the same process as distributing, but what it's telling us to do is to multiply the first term that's in each parentheses together. So 2p times 7p is 14p squared. Then it's telling us to do the outer terms. So that would be these two terms that are farthest out from the middle of our problem. So 2p times 4 would give us 8p. Then we're doing the inner terms. So the opposite of outer would be inner, which is 1 times 7p, the most inside terms of the problem. And then last, we would do what's left over, which is also the last term in each parentheses, which is 1 times 4. What should happen the majority of the time is that these middle terms are like terms, and so we will add them together. Remember, when we add like terms, instead of multiplying, that it stays p and we just do 8 plus 7. So this is 15p in the middle, and it is in standard form. 11 and 12 are actually special products, and you can use the special products to figure out what the answer would be, or you can actually just multiply like normal. And so it kind of depends on whether or not you see the special product. On 11, if you don't realize it's a special product, what you do need to do is say that if I'm squaring something, that means I'm multiplying it together twice. And so we need to rewrite it where we have 2 parentheses instead of 1, and then we either FOIL or distribute. And so if whichever one I do, I end up doing the same thing. I end up doing 4r times 4r, which is 16r squared. And then I end up doing 4r times 3, which is 12r. And then I do 3 times 4r, which is 12r. And then I do 3 times 3, which is 9. So then, like last time on number 10, the middle terms are like terms. Make sure that you think 12 plus 12 is 24. They don't cancel each other out because neither of them are negative. So this is 16r squared plus 24r plus 9. The pattern that's happening here, and if you didn't realize you had to write it twice, you would have gotten part of this answer anyway probably. We want to square the 4r and get 16r squared. We want to square the 3 and get the 9. The middle term comes from doubling the 2 terms multiplied together. So doubling 4r times 3, which is 2 times 4 times 3, which is 24r. So that's how that pattern works. On 12, this pattern is a little bit easier to recognize in some ways, I think. Or it's easier if you don't recognize the pattern because it has both parentheses written out. We want to do k times k, which is k squared, k times negative 8, which is negative 8k, 8 times k, which is 8k, and 8 times negative 8, which is negative 64. This time the middle terms are opposite signs and cancel each other out so that we get k squared minus 64. You don't need to put 0k in the middle, and it's really a better answer if you don't. The pattern here is that if I recognize that these are the same thing just with opposite signs, our middle terms will always cancel out, so that it always ends up being k times k and 8 times negative 8, which is k squared minus 64. Now we want to move on to harder problems where we've got a binomial times a trinomial, and so what we need to do is take the x and multiply it all the way through, take the 2 and multiply it all the way through, and then add like terms. So x times x squared is x cubed. X times 4x is 4x squared. X times 4 is 4x. Then we're going to do the same thing with the 2. And I'm going to be strategic about this. 2 times x squared, I'm going to write that underneath this other x squared so that here in a second I can just add in my columns. Then I'm going to do 2 times 4x, which is 8x. And then I'm going to do 2 times 4, which is 8. So the x cubed doesn't have anything to add with. The x squareds add together. And then 4 and 8 add together and get 12. The 8 doesn't have anything to add with, so this would be my answer. So this would be a situation, since 14 is really similar to 13, you might think about pausing the video to see if you can get this one on your own. So we do 8x times 4x squared, which is 32x cubed. Then we do 8x times 4x, which is 32x. And then we do 8x times negative 7, which is minus 56. We do 7 times 4x squared. I screwed up my x's here. This is x squared, and this has an x. Sorry about that. 8x times 4x is 32x squared. 8x times negative 7 is negative 56x. 7 times 4x squared is 28x squared. 7 times 4x is 28x. And 7 times negative 7 is negative 49. We've got some kind of big numbers to add together here, like 32 and 28. You get 0 and you carry your 1 and get 6, so that's 60x squared. Here I need to subtract these, and it's going to be a minus sign because 56 is bigger, so that's 8, and we borrowed, so that's 28x, and then minus 49. And this is our answer. Now we're moving on from multiplication, and we're going to talk about factoring, which is the opposite of multiplication with polynomials. So this first section says to factor the common factor out of each expression. So what we're looking for is a number that we can divide everything by, and or a variable that we can divide everything by. So for instance, I look at 10, 2, and 6 and say, what's the biggest number that I can divide into all three of these, which would be 2. If all I can divide in is 1, then I don't even worry about dividing by anything. Then not all of these have x, so I can't divide by an x because the 6 doesn't have an x. If I try to divide by an x, I end up with an x on the bottom of a fraction, and I don't want that. So what I need to do is write what I divided by on the outside of a set of parentheses, and then go ahead and divide. Negative 10 divided by 2 is negative 5. The x stays the same because we didn't divide by an x. 2 divided by 2 is 1, so then I just have 1x. And then negative 6 divided by 2 is negative 3. This is my answer. I can check my answer by using the distributive property to see if I get what I started with. And that might be super helpful if you're on a test and want to get as good a grade as possible. On 16, if I just look at the numbers to start off, you might be like, oh, 3. I can divide 3 into everything, but there's a bigger number, and we always want to pick the biggest number. So we can divide all of these by 9. And then when we look at the a's, they all have a's, and we use the smallest exponent because that's what will go into all of them, is whatever is the smallest number of a's. If I pick a to the 6th here, it works for that, but it doesn't work here because I subtract and get a negative exponent. And even if I pick a to the 4th, on the last one I would get a negative exponent. So I want to pick the smallest exponent for a that I have so that I know that it will go in evenly. So we're going to divide everything by 9a cubed. That's what goes outside our parentheses. Then we divide. So that 9 looks like an a. We do negative 36 divided by 9 and get negative 4. We subtract their exponents because we're dividing and get 6 minus 3, which is 3. Negative 27 divided by 9 is negative 3. 4 minus 3 is 1. You can write the 1, but you don't need to because we understand that there's a 1 there when we don't write it. 45 divided by 9 is 5. And a cubed over a cubed cancels each other out completely, which is what we want to have happen, because at the end of this, they should not all have a's, or we didn't pick a big enough exponent for a. So again, we could distribute to check our answer and see if we are correct or not. 17. what number can I divide into all of these? 4 goes in, but so does 8. So all of them are negative, which means I can take the negative they all have in common. And then I would look at these variables separately. V I have in each of them, and I actually have a v squared that I can take out of all of them. Because if I take it out here, then it cancels. If I take it out here, I subtract and get something. If I take it out here, it cancels. I cannot take out a u because there's not a u on this last term. So let me add the -8 in here as well. All right, so -16 divided by -8 is a +2, and I would still have the u to the 5th. -40 divided by -8 is 5, and 4 minus 2 for our exponents gives me 2, and I'd still have the u there. 72 divided by 8 is 9, and it changes to plus. And the v's cancel out, so this is my answer. By the way, like if this had been an 8 right here, and that would make this cancel out completely, we would want to put a 1 in this place instead of nothing, because we have to show that there was something there. We're dividing and we say, oh, that equals 1. It doesn't equal nothing if you have something like 8v squared over 8v squared. That's not equal to 0. It's equal to 1. So keep that in mind if that happens to you. All right, we're going to factor things that are of the form ax squared plus bx plus c using my favorite method, slide and divide. So this method requires us to take the number at the beginning of our problem, 3, and slide it to the last number, which is -6, so that we get n squared plus 7n minus 18. Then we look at this -18 and we say what multiplies to get -18 that adds to get 7. So that might require, what we're doing is we're coming up with factors of 18. So factors like 1 and 18, 2 and 9, 3 and 6, that's actually all the factors. If I make one of these negative, one of the numbers negative, since this is supposed to multiply and get a negative, what pair should I pick so that when I add them together, I get this middle number, which is 7? Well, so really what I'm looking for, since one of them can be negative, is what subtracts to get 7, which is the 2 and the 9. From there, I have to decide, should this be -2 plus 9, or should it be -9 plus 2? Which one gets the negative, the 9 or the 2? And so it's this first way that's correct, because it gives us a +7 versus a -7. So n minus 2, and then n plus 9. Now, this is called slide and divide. We did the slide part earlier when we moved the 3 over to the -6. Now we're going to do the divide part and divide both of these numbers by 3. And to finish it off, if it doesn't divide like 2/3, we take the bottom number and we move it in front of the letter and get 3n minus 2. If it does divide, like 9 divided by 3, we go ahead and divide it. Or if it simplifies, we go ahead and divide it. Or we go ahead and simplify it, and then see what that ends up giving us as a bottom number. I think that should happen on one of these. Fingers crossed, so you'll see what I mean. So 19, slide the 2 over to the 9 and get m squared minus 9m plus 18. We're looking for what multiplies to get 18 that will add to get -9. So 18 again, so same factors. And the factors we want this time are 3 and 6. Now, in order to add and get -9, we need them both to be negative. -3 minus 6 is -9, or -3 plus a -6 is -9. And that also makes sense because in order to multiply and get a positive, they would both need to be positive or both need to be negative. So this is m minus 3, m minus 6. A big thing that people forget to do is the divide part. So I want to take this now and divide both of these numbers by 2. And so if it doesn't divide like on this first one, we move the 2 in front of the letter. If it does divide, we go ahead and divide. If you wanted to check this, you could FOIL or distribute out and see if you get what we started with. And if you don't, that means that you need to go back and figure out where your mistake is. 20, slide. So x squared plus 17x plus 42. So we want to figure out factors of 42. I like to really methodically go through the factors personally. To me, it almost seems like it saves time, but I know that a lot of students in particular would not enjoy doing that and will just try to come up with the factors off the top of their head. There's nothing wrong with that unless it takes you forever to do it. 3 and 14 add to get 17, so that's what I want, and that was not something that would have easily come to most of our minds. So we put the 3 and the 14. We're going to divide these both by 6. This is what I was talking about where we simplify if possible. So that 3/6 is going to become a 1/2, and the 14/6 is going to become a 7/3. You have to do that or this method ends up giving you the wrong answer. Okay, you absolutely have to simplify, and then once it's simplified, that's when you move the numbers in front. So this is 2x plus 1 and 3x plus 7. And this last one, if you have not already tried to do this on your own, I recommend you pause the video and try it. This one's actually, this one's tough because we get a big number here, but I believe in you. I think you can do it. So multiplies to get 180, adds to get negative 36, and I actually pretty sure that I thought of it right off the bat. 30 times 6, which they both would need to be negative. So if you don't think of it right off the bat, remember to make a list of factors. If you're really methodical about it, then that will help you not skip anything. That might be the key thing you need. So now that I've got it written out, I divide by 9. I need to simplify. This first one simplifies by 3. They both simplify by 3. And then move the 3's in front. 3n minus 10 and 3n minus 2. So that is slide and divide. If you don't like that method, if it doesn't make sense to you, there are other methods of doing this that you can look up on the internet even and figure out other ways of doing it. So keep that in mind. Factor each completely. Hint, check for a common factor first. So we want to, before we actually try to do slide and divide, we want to try to divide everything by a number in common. For instance, all of these are divisible by 2. So let's write down the 2 and divide by 2. And then we're going to ignore the 2 right now and try to split up this parentheses. Now, because we got rid of this number that was in front of p squared, it's like there's a 1 here. If we slide a 1, we still get 81. So we don't even have to really do slide and divide anymore. We can just say, well, what multiplies to get 81 that adds to get 18, which would be 9 and 9. The 2 is still on the outside. We're not going to move the 2 inside at all. We want the 2 to stay out because that is a part of factoring, is taking out the common factor. Then we can also rewrite this because it's the same thing in our parentheses both times. We can, I'm screwing this up. We can write it just once with a squared. So this was actually a special product, which I can recognize by saying that p squared has a square root and 81 has a square root, and 18p is double what those two things are multiplied together, like what we were talking about earlier. But you don't have to think of it like a special product. if you just factor it. 23, they have a 3 in common. So that's 3, and b squared minus b minus 2. We're going to split this up into two parentheses. So what multiplies to get negative 2 and adds to get negative 1, which would be negative 2 and positive 1. It's really easy to get those signs backwards, so make sure that you are thinking, okay, negative 2 plus 1 gives me a negative because the 2 is bigger. Let's see, I don't have anything I need to divide by on 24, so we just go straight to our parentheses and say what multiplies to get 40 that adds to get negative 10. So I'm thinking, I keep thinking 4 and 6, but that's not what multiplies to get 40. So let me make a list. 1 times 40, 2 times 20, 3 doesn't go in, 4 times 10, 5 times 8. You know what? That's all of the factors of 40, and none of them actually will add to give us negative 10, which means that this is not factorable. Typically, that will be something that very rarely happens. Like, you should not put an answer as not factorable unless you know it's a possibility because your teacher told you that you could have some that are not factorable. But even then, you want to make really, really sure that you've thought of all the factors and actually sit there and like add them or subtract them to see if you can get the middle number. Because it's not very often that a teacher would give you like 8 not factorable problems out of 10 on a quiz or something. If you're getting that many not factorable, you're just not factoring right, probably. On 25, we're missing that middle term. If we wanted to, we could rewrite this with the middle term, and that middle term would have a 0 in front, not a 1. A 1x would mean that they would have had to put it there. But we could think of it like there's a 0x, which means we're looking for what multiplies to get negative 4 and adds to get 0. What works for that is positive 2 and negative 2. So this is the opposite of that special product from earlier where we had our middle terms cancel out, called the difference of two squares. So we have x squared and 4, which they're both squares because you square something and get them. And then there's a subtraction symbol in the middle. So that means that I have a special pattern that if I recognize that, I can say, oh yeah, that's x plus 2 and x minus 2. Now we're going to do, this is the last set of stuff for this review. We're going to solve each equation by factoring. So the steps we want to do when we're solving an equation by factoring is we want to get everything on one side in the standard form, and it'll make it immensely easier on us if the squared term is positive. So for instance, I would not want to, for many reasons, move the n squared over to the right side because that makes it negative. I want it to stay on the left where it is positive. I do need to move the negative 8 over so that I get n squared minus 6n plus 5 equals 0. I want it to equal 0 so I can use this really cool zero product property in a moment. I need to start off by factoring this. One of the challenging parts of this section will be knowing what method to use to factor, because we kind of did 3 different ones, and so how do I know which one to use? I'm not going to use slide and divide because there's a 1 to slide. All I need to do is think what multiplies to get 5 that adds to get negative 6, and put an n in each of these. So that would, there's only one thing that it could be, 5 and 1, but they do both need to be negative so that when I add them together I get negative 6. Here's where the zero product property comes in. We need to take each parentheses and set it equal to 0, because if I multiply two things and I get 0, then one or both of them has to be 0. So we take these sets of parentheses and make it into two equations where they equal 0. This first one we'd need to add 5. The second one we would need to add 1. And we get two answers, as we most often do with quadratics, 5 and 1. 27 is a little bit different because we don't have a plus a number term here. So instead of factoring it using slide and divide or factoring it into two parentheses like we did on 26, what we're looking for is what do these have in common. And so we want to say, I know that they both have an r, so I'm going to divide them both by r. That r doesn't go away though. We're not allowed to divide by a variable in an equation and have it completely go away. When we divide by a variable, we need to write it outside, like what I have. And then on the inside, we go ahead and do r squared divided by r to the first, which is r, negative r divided by r, which is negative 1. And then when we go to split this up, the r is one of the things that we're multiplying and gets set equal to 0. The r minus 1 is the other part that gets set equal to 0. And so this is already solved. R equals 0 is one of our answers. The other answer after we add 1 is 1. So our answers are 0 and 1. Now we need to put things in standard form on one side of the equation, and we want n squared to be positive, so I'm going to move them over to the left, even though that might seem like more work. When we move them, we switch the signs, so this will be 6n squared. We're going to put the negative 18n next, and then subtract 168. It's really important that we remember to put it in the correct order so we don't trip ourselves up when we're factoring, and that the n squared is positive, because we have not actually really factored into two parentheses anything that has a negative in front, and it just makes it weird. The other thing is if we moved everything to the right and we did have a negative, we could divide by a negative. At this point, we either need to try to slide and divide, or it'd be more helpful actually for us to say, oh hey, I can divide all of these by something. If you can divide the first two by something, you should give that a try, even if you're not sure it goes into the third one, because you can do some quick division to see if 6 will go into it. Pretty sure it does. I said on the last problem we're not allowed to divide by a variable in an equation, but we are absolutely allowed to divide by a number and have it just go away, because 6 divided by 6 is 1n squared. Negative 18 divided by 6 gives us negative 3n. Here's where my mental math comes in. 6 into 16 goes twice with 4 left over, so I'm looking for 6 into 48, which is 8. And 0 divided by 6 is 0, which is why it's okay for us, or part of why it's okay for us to divide by 6, because we still get 0 on the right. Now I want to factor this. I don't need to slide and divide because I got rid of what was in front. It splits up into n and n. What multiplies to get negative 28, that adds to get negative 3. And that would be hopefully the most obvious thing for 28, which is 4 and 7. The 7 needs to be negative, the 4 needs to be positive. And then we will put each part of this equal to 0. Add 7. And subtract 4. Because we're just solving like we did way back at the beginning of the school year, simple linear equations. So our answers are 7 and negative 4. 29, all we got to do is add the 3 to get it in standard form, all on the same side. So that's nice. 5x squared plus 9x minus 2 equals 0. And this is a case where there's not a number we can divide all of them by, so we do need to slide and divide. And we get x squared plus 9x minus 10. At this point, I don't want to put equals 0 because these two things are not actually equal. Slide and divide is an algorithm that we can use to come up with the correct factors, but in between where we start and where we end is actually not super correct mathematically. You're not allowed to just move a 5 like what we just did, but we're allowed to use this to figure out what our factors should be. So I want to know what multiplies to get negative 10 and adds to get 9, which is positive 10 and negative 1. I want to divide by what I slid earlier, which was 5, so that I get x plus 2 and 5x minus 1. this is the point where I can go back and say equals 0, because this is the point where if I multiply this out, I do get what I started with. So these two things are equal. And so I need this step right here where I have it written out, because we were asked to solve this by factoring. And at this point is where I've factored 5x squared plus 9x minus 2. So I'm going to set each part of this equal to 0 to finish solving. So I would subtract 2 and get x equals negative 2. I'm going to add 1 and divide by 5. So that x is 1/5 and x is negative 2. When we end up having to use slide and divide to factor, I'm pretty sure always actually is the correct word, always get one of our answers to be a fraction. If we don't, we either did something wrong or we didn't really need to use slide and divide, one of those two options. So we need to be able to solve things like the second part of that, where it's a two-step equation, but it's not going to divide evenly, so we're just going to write it as the simplest fraction that we can. And finally, so let's see, adding 7v squared over would be helpful. We're going to need to arrange this in the correct order, so v squared and then v and then our number equals 0. I do need to slide and divide. And at first you may be thinking, oh, this is 42. I don't know about this. Yeah, it's the meaning of life, but I don't know about factoring it. But anytime you see this where the numbers are super close together, 42 and 41, then you need to check out that factor that sometimes gets overlooked, 1 and 42. And if we want to be able to make one of them negative and get 41, it better be the 1. 42 minus 1 gives us 41. So v plus 42, v minus 1. We want to, I was not supposed to put equals 0 there. It does not equal 0. We want to divide by 7. If it divides, we divide. And if it doesn't, we move the bottom number in front. Now I can put equals 0, and I can set each part of this equal to 0. So subtract 6, add 1, and get 1/7. So my two answers are -6 and 1/7. And that is a review of what's Chapter 10 in my Algebra 1 book. It's all about polynomials, operations with polynomials, and just in general, a fun time. Happy studying.